All right, guys. So for the derivative of an exponent, I think it's fairly intuitive. Um, and once you look into it, you're gonna see that's kind of easy. So let's say I have f of x equals x squared. Okay. When you do the derivative, and for now I'm just gonna show you the answer. Okay. But when you do the derivative of this, you end up with 2x. Let me give you another example. Let's say I have f of x equals, I don't know, 3x cubed. When you do the derivative of that, you end up with 9x squared. So, what's going on? Ladies and gentlemen, there's two things going on, okay? The first one is that the exponent multiplies below. I'm gonna explain what I mean by below in a second. And the second thing that happens, okay, is that the exponent sort of like loses 1, okay? The exponent gets -1. So, this is a very non-fancy mathematical way to explain it, but you're not here to understand the textbook definition. You're here to understand what the fuck is going on. So, intuitively, the exponent goes below. See? So this 2 went down below in front, so you ended up with 2x. Um, so that's for the exponent going below. And then the exponent gets -1, that 2 minus 1. Okay? So, this 2, all right, goes right in front, multiplying. Okay, so you have 2x to the power of 2 minus 1. 2 minus 1 is just 1. Out of convenience, you don't write it. Okay, out of convenience, you don't write it. You end up with just 2x. Okay, over here, it's no different, right? So the 3 goes down in front, multiplying. So the step in between is 3 times 3, x to the power of 3 minus 1. So this 3 times 3 gives you this 9. This 3, this 3 minus 1 gives you that 2. That's all that happens in a derivative of an exponent. Like literally dead ass, it's all that happens. The exponent multiplies quote unquote below, the exponent gets -1. And that is it. Okay? That's it. If you understand these two examples, you're pretty much good to go. And now I'm gonna show you the weird shit that can show up. Okay? So the weird shit that can show up is, for example, let's say I have, I don't know, f of x equals x squared divided by 2. All right, so again, I follow the same process. See, the exponent multiplies below, the exponent gets -1. So if I go ahead and do that here, what happens? Well, the exponent goes below, see, so I end up with 2x 2 minus 1 divided by 2. So this 2 goes away with this 2, and I end up with just x. And so when you have fractions, okay, you have to be careful of how that interacts. See? Maybe a more friendly example, or I don't know if friendly, but something you're probably going to encounter. Let's say you have 3x to the power of 4 divided by, I don't know, 8. So if you go ahead and do the derivative of this, okay, you end up with this 4 multiplying in front. So you end up with 3 times 4 to the power of, with x to the power of 4 minus 1 divided by 8. Okay? Always do this step in between. Okay, some people try to do it everything like in one go. Dude, just do the step in between, do the 4 minus 1, write it down, be organized, make sure you get full credit. Okay, people lose points because they don't do that, what I call extra step. Okay, just do the fucking extra step. It's worth it. Okay, so 3 times 4 gives you 12, x to the power of 3 divided by 8. Right, and so now you can simplify a little bit because we're in the world of fractions. Bada bing, bada boom, you end up with 3x cubed divided by 2. I divided by 4 everything. So that's the kind of stuff you can encounter, okay? And I'm going to end with the following idea, which is a little more complex, okay? But I'm sure you can handle it. Let's say you have f of x equals, I don't know, equals 1 divided by x. Okay, this is a classic. The teachers always like to put it. So if you do the derivative of an exponent here right away, unless you know the steps in between, you're gonna just get lost. Okay, so the steps in between is that before you do the derivative of the exponent, okay, before you do the derivative of the exponent, put this x on top, okay? Put this x on top because it's what we've been used to this whole time. In all of these examples, the x has been on top. So here the teacher throws you a curveball and says, hey, Here's a scenario where the x is not on top. Okay, what do you do there? See? Start off by throwing it on top. See? So this x on the bottom is to the power of 1. See? And to throw it on top, okay, you end up with x to the power of -1. See? Anytime an exponent has a negative, it's sort of like flipped. See? That's the idea when you have an exponent that's negative. It's flipped, okay? If it's on the top, it goes on the bottom. If it's on the bottom, it goes on the top. Let me give you an example. Let's say you have, I don't know, man, you have x to the power of -3 divided by y to the power of 2. See? What would this turn into? This would turn into 1 over x to the power of 3, y to the power of 2. Same example, x to the power of -3 divided by, actually no, positive. See, positive, positive. And then I have y to the power of -2. This ends up being x cubed, y squared. Period. Okay, what does the negative do? It makes it go on top. See? Or it flips it. This -3 made it go on the bottom. All right, what if they're both negative? Ooh, spooky, right? Oh, what happens here? Dude, it's the same thing. Chill out. The y is going to go on top. The x is going to go on the bottom. They both flip because of the negative. They both flip, and that's it. Period. Okay? So, take that extra step before you do the derivative. I have not done the derivative yet. Okay, before you do the derivative, flip it. It's going to be easier on you. Once you flip it, you do the derivative. Same idea as before. This -1 goes in front. So you end up with -1 times x, with x being to the power of -1 minus 1. Yes, it looks weird, but if you follow the process, you're going to get the answer. So this, well, the negative 1 is just -x, see? And on the top, I end up with -2, see? And if I throw this on the bottom, following the rule, because, it's negative exponent, you end up with -1 divided by x squared. And that's it. Okay, that's literally it, see? Again, here I'm just leaving it fancy. Technically, this is also correct. See, I'm just applying the thing that it's a negative exponent to leave it more pretty, but both answers work. Whatever. See, I'm gonna finish with this last idea that just came to my mind. See, so now that you understand well the derivative of an exponent, you can actually use it when you have square roots. Ooh la la. So if I ask for the square root if I ask for the derivative of the square root, okay, some people memorize like the solution, okay? But actually, square root of x is no different than, this is before the derivative, this is no different than x to the power of 1/2. See? I have a video explaining this on more detail. It's called square roots, square roots 101. And so before I do the derivative, I leave it with an exponent on top so that it's easier to do the derivative of an exponent. Now when I do the derivative now, this 1/2 goes in front. See, so I end up with 1/2 x to the power of 1/2 minus 1. And all this ends up being is 1/2 x to the power of -1/2. See? And so now I leave it a little more pretty because, it's convenient. And so because it's multiplying and because it's fractions, I end up with x to the power of -1/2 divided by 2. And if I want to leave it really, really pretty, this ends up being 1 divided by 2 to the power of x, 2 times x to the power of 1/2. And if I want to leave it even more pretty, I return it to its square root version, and it ends up like that, okay? So yeah, that is why the derivative of this square root has a 2 in between, okay? It's because technically you're doing the exponent derivative midway. A lot of people don't get that, and it's because a lot of people don't understand the sort of steps in between that I'm talking about. See? So that is the derivative of an exponent, and even through it, I showed you a little bit the derivative of the square root. So ladies and gentlemen, I hope it helped. And yeah, take it easy. I'll see you around.